So, hello, uh, welcome everyone, and I think this is the first of the year, the first AI engineering learning, the AI learning club of the year, finally picking up. And today is one of the few last chapters of that we're exploring. This is chapter 9 of the AI engineering book. There's only 11 chapters, and we are on the ninth chapter already. So almost finishing up. No, this is not the chapter I was looking for. It's actually the eighth chapter. Yeah. So there are 10 chapters, and we are into the eighth chapter, dataset engineering. Um, I prepared a bit of content for this one, but we can discuss later. So for me, the key parts of this chapter was the data is we can use for fine tuning and training. We can get if we cannot change the number of parameters of a model, change the data set is often very useful and can yield really good results. And even if we are not training new models, if we're just fine tuning, and some of this that were brought in also is very useful for evaluation. So we are having many discussions over how to create data sets for evaluation of AI features, and this is something that came up like this part of it as well. So the quality of the data, if you have too much, it's like it doesn't matter if you have 10 million examples, if all of the examples are the same web page. It it won't help very much. So it's not too useful. But one point that I found it interesting on the document is that even with five of the 5 or 100 examples, you should see already improvement with fine tuning. So you don't need to add a lot of data in order to be able to see improvements with fine tuning. So that's very interesting because we don't use any sort of fine tuning in GitLab. We have some exploration happening in fine tuning, but we don't do much. Perhaps we could, we only use stock models, but perhaps we could get some good outcomes for dual chat and for code generation using this part on .com. And PAFT, which is parameter efficient fine tuning. It's a method that doesn't fine tune the whole model, but just some of the weights of the model, is a good alternative with 50 to 100 examples. But the problem with getting good data is that getting data is expensive, getting good data is even more expensive. You need to vet the, the entries. And it's just a process that needs to be followed. You can use LLMs to go through the data and quantify the quality of the data, but that's also expensive. You can go for open data sets, but the reality is that most data sets are like for validation, for training is a really good idea, but for validation is not so good to go with open data sets sometimes because open data sets are probably already part of the training data sets of the models. So the models have already likely memorized the results. So validating an AI feature with that is not really useful. And especially in scale, maintaining consistency, quality, and duplication is very complicated. But something that can be done is instead of using good quality data set for everything, use goodish quality first at scale for a first round of training, and then later on use better quality of data for a second round of training. So, for example, instead of starting just with vetted pages of the internet, use every page for training, and then fine tune with a selected number of well-crafted pages. Or instead of starting with human-generated data, initially start with synthetic data, and then later fine tune more uh, with more human-generated and really rigorous data that we created. And one example that I liked is always we start with the idea of how do we find data sets to even start with. This is a big problem with evaluation. And there is a bunch of data sets that we can use on the internet for inspiration, like dataset search on Google. And you can just search through data sets. Wait, this is not here. Okay. But one point that I really liked and something that we can use a lot that we haven't been using too much at GitLab is data synthesis and augmentation. So augmentation of data is you transform existing entries to generate new entries. So for example, in images, you have one image for training. You can flip on the horizontal axis, flip on the vertical axis, tilt, rotate by 10 degrees. These are all transformations over the original image. This is called data augmentation. And every one of those can help the model be better at not memorizing the image specific, but understand the concept that is around it, right? Um, so for example, in code, we can use data augmentation in we can change classes name of classes for example, we're trying to use and explain to validate and explain feature. Instead of having just one name, we can of function, we can have multiple names of the function so that the entry is different. Or we can use synonyms to augment the data set. And synthesis is full-on creation of new data. So one example that we are exploring on the refactor dataset that we are on the refactor feature that we are trying to work with dataset is pick up code that we have on GitLab, use LLMs to unrefactor the code, create worse versions of the code so that we can put the LLM that we're actually trying to evaluate, see if it actually improved or not. This is a way to create data at scale. And you can see here how you can get pretty crazy very quickly. Another example where we use this is on documentation search, so of evaluation. So how we do is we pick a lot of pages from our documentation, we generate a question based on that documentation, and we try to get the duo to answer the question, the original question. So this is one way to scale data creation without adding a lot of manually done stuff. Uh, but then you can also you can go crazy because this is even one of a proposal that we had in the beginning to do function testing is we can also generate the tests for a question. So for example, we have workflow or we are trying to create a function that does something. Instead of just creating the code, we can also create the tests and see if they match each other. So there are many ways of synthesizing or augmenting data for evaluation and for training. But those were the points brought that I understood from the book or that caught my attention. And yeah, open up for discussion. Any ideas, any discussions that you guys want to bring? None?
I have one, I suppose.
Yeah.
So one of the issues I'm working on now is creating a data set for open tabs for code suggestions. So when you write a code suggestion, it automatically recognizes what tabs you have open in your editor and then feeds that into the prompt as well to enhance the prompt with that extra context. So the question is how to write a data set for this. And it's going to be like like Eduardo said, scaling data sets can be difficult, but this one is going to be just a starting point of like 20 examples for code completion and 20 examples for code generation. So one of the ideas that Gosha and I had was to open up two related classes and then delete piece of the code in the class that in or in the service that calls a different class and then see what the suggestion is and then use that piece that you deleted as the ground truth to be able to compare with whatever the code suggestion is. So I don't know if anyone has any ideas on how to improve this or what you think of this potential idea of creating a data set for this purpose because it's quite manual and then also depends a lot on like what you decide to delete and maybe even without that extra context, like how do you know that the context is what enhanced the
Mm-hmm.
response versus whether the LM would have suggested that anyway based on patterns in the coding
Mm-hmm.
language.
Yeah, this is the same approach used for code suggestions, Missy. That
Oh, cool.
right? So we scan some repositories, you get the source code, then you delete parts of that source code, and now that deleted part is the truth, right? The ground truth.
Yeah.
And then you the evaluation side that we can now having a ground truth, then you can use cosine similarity, for example, to compare. I think it's a good start. In your case, I wonder if cosine similarity would have the granularity necessary to discern between are you using a class from this project or are you using an external solution that is not particular to that project, right? Because right now we want to test if the right references, if you're really leveraging the context in that project and thus using definitions, symbols, classes in the deleted code or not. Um, but I think it's a good start because yeah, it's the same approach that we use for code suggestions.
Yeah. I I would find it interesting as well to do for each sample experiment twice. Do one with the added context and one without the added context. With and without the open tabs and see the difference. Ideally, you want to see a better response with the added context, right? So this is how this is one of the ways that like you are trying to evaluate here whether the added context improves or not the result and by how much. And one is baseline of without it, right? You baseline to not have context and then you add the context. On this case, I'm trying to think if it should be end to end or it should be just the prompt because the end to end would be very difficult here because you have to have the open for example, do a chat, we can do the full cycle of evaluation, right? We can just make a question and do a chat fetches the everything like fetches the database for documentation and so on and so forth. On this case, it's a little bit more difficult because you cannot tell like the client to open two tabs. So you need to send already the tabs that are available to the AI gateway. So I think that could be a way. This could be also automated in some ways. So if you know that some class uses a different one, you can automate a way to create these examples.
It's
So,
really automatable, Eduardo, because once you created the data set, right, it would be tricky to create this data set, Missy, because you need of course, the part that we are deleting, right, the source code that you are deleting the code from, but also the composing context. And then how do you come up with this composing context, right? How many files would you use? Are you going to use the whole project, for example, or not? Yeah, need to experiment a little bit.
so I have a question about what Eduardo recommended of testing twice. So would you add another column into each example to just say context included, true, false, or something to be able to track that metric as well?
We could just run a first example or not have a data set with the full, but have a data set without the examples, right? A data set which is just it would be technically a code generation, simple code generation, right? It would be
Yeah.
very much similar to a code generation data set. And then
Hmm.
that would be our baseline. And then the other data set is with added context, and that will give you how much it's better, uh, the approach. It's more of an exercise of like a more academic curiosity than actually useful, but it's also a sanity check. Like it should be at least better, right? Like what's the point of doing this if it's not at least better? Then
Okay, that makes sense.
um,
Now, one more point on having a baseline. It's very important. This is also something that we're using to validate the fine-tuning approach. So we are fine-tuning a model into one project and then using that model against to complete make code completions for that project, right? And then the baseline is the fine-tuned model better than just the base model, right? In our case, would just the difference just using one model or the other, but in yours, it's using the context or not, right? Then the question is, where should you put the context? Should it lie in the data set? Should you have two data sets or just a toggle in the eval itself?
I'm trying to think of other ways to test in the open tabs and trying to automate this. I don't think we need to scale right now. Just having an idea and a baseline like uh, would already be enough. But if we want to automate, maybe if we use um, with Ruby, sometimes difficult, but if we know that a file mentions a specific class, for example, a service mentions a specific class by another service, like you mentioned, then we know exactly which file is that, right? If it mentions by the full name of that thing, then we could automate this, or we could find references of that and try to automate this process. Just an idea. Like for example,
Okay.
let me try to find something that does this. Oh, my Ruby mine is closed. But yeah, we can talk about it. I'm just going wild on this idea now.
Mhm. Yeah, one way to find the symbol information is C tags. It's
Yeah.
just a project that parses your repository, right? And creates symbol information. So you can have, for example, go-to definitions in IDEs. So the engine that powers these features is C tags. And with C tags, you know that that particular symbol, right? A symbol being a class, a function, any other definition, is in this file at this on this line. And with this, you could fetch the context for the symbols being used in the thing that you're trying to autocomplete. But yeah, it's something very customized. Maybe there's an easier approach.
And I think one thing that we could also look at is evaluation should also evaluate the bad cases, right? It's not only the cases where the context makes sense, but also the context where the context doesn't make sense. So suppose that your case, you're coding and you have a completely unrelated tab opened. Is the model good enough to not use the provided context when it's bad, right? Like, is it something we want to explore as well? So to having some of those examples, like for example, we're building a data set for tool evaluate whether the dual chat is choosing the right tool. We have to have examples where no tool is chosen in the first place, right? So that it's because sometimes it's not ideal. So in this case, I would also try to include some examples like where the provided context is completely nonsense, like some blabber and yeah.
Mhm.
Cool. Any other discussion point? Any other ideas?
I do
We
have
can
a
also,
question.
oh,
Wait,
sorry.
Dimitri.
Oh,
Yeah.
go ahead, please, Dmitry.
Just want to mention we could consider using something like tree sitter to find the classes, the
Mm-hmm.
files to attach, or even git grep in some cases.
Mm-hmm.
Yeah, Tree City was being used for code suggestions, but I don't think we use it anymore.
And we do. Not for the evaluation. Oh, well, we use for generation, but I don't think we do it to add more context, but I don't think we do for suggestion, for evaluation.
I have a question, Eduardo, maybe. You mentioned some techniques for augmenting data sets, which is the examples for images, for example, that are very easy to understand, right? Crop it, flip it, etc. Do a
Yeah.
bunch of transformations. I wonder, do you know if we have an example of we augmenting data sets using maybe a similar technique at GitLab? I remember only one example was to test duo chat at the very beginning, where we had just a few questions collected from feedback, and we asked an LLM to just create variations or different ways of phrasing those questions, right? But
Mhm.
not sure if this is being used in the data sets right now. Do you know any other example?
I don't, I can't recall. I know the synthesis of documentation and the idea of refactor, but I don't know any other case where you're actually doing like multiplying the number of examples we already have. Not yet. It's a good idea to try exploring as well, like how we can. It's a lot easier with images, but this could be change the language, for example, translate into a different language, or remove some random words or change some words by its synonyms, or transform the sentence into a different tone, like transform the sentence, the question into a question as a poetry. Does it work? Like, so that kind of
Yeah, a quote from Thorsten was, I phrased this as if it was being phrased by a German speaker or a
yeah,
non-English speaker. That was a cool
yeah,
one.
cool. Any other discussion point? Someone that wants to bring something? Stefan, you were here. Oh, Stefan is not here anymore. But yeah, there's AC. Oh, yeah. Oh, thanks, Omar. Do you want to voice your?
I look, no, honestly, this is just a quick Google, but it's giving some examples of it mentions what you said about the replacing with synonyms and rewording it, but it's just got a list of other approaches. Interesting to me, the one where random word insertion and random word deletion.
Mm-hmm.
Um, like random, I guess that is that good? I guess it does change things up in an interesting way. Yeah.
Yeah. It's kind of like Chaos Monkey testing. Like you just delete random functions and see if it works. Yeah, cool. Okay, so yeah, thanks everyone for joining me on this first learning club of the year. We're almost done with the book, and from this, I really want to read the Llama 3 paper. They mention a lot of they used a lot of different unique approaches to data augmentation, but we're almost done with the book. Only 2 chapters left, which is quite an achievement, I would say, to have a group this size going through all of this time. So I'm feeling pretty great about this. Thank you very much. Thank you, everyone, and have a great day. Bye.
Thank you.